Assalamualaikum and hi everyone. So today we will present about alcohol and phenols. This is for our organic chemistry subject CHM 207. I'll pass to the first presenter.
Assalamualaikum and a very good day to everyone. Today I would like to present about alcohols in chemistry. Alcohol is a class of organic compounds that can be identified easily by the presence of the hydroxy group or OH group attached to a saturated carbon atom. Alcohols can be classified into three types, which is primary, secondary or tertiary, depending on the position of the hydroxy group on the carbon chain. In this presentation, we will explore the naming rules of alcohols, their classifications and the chemical reactions that alcohols typically undergo.
Nomenclature of alcohol and phenols. Alcohols are named based on the longest carbon chain that includes the OH group and then change the E in the alkane name to OL. For example, ethane to ethanol. Then number the chain so the OH group gets the lowest number. Phenols are aromatic compounds with OH directly attached to a benzene ring. The OH is always at position 1 and then number the ring to give substituents the lowest possible number. We can use terms like ortho position 1 and 2, meta 1 and 3 and para 1 and 4 for two substituents, and make sure we use numbers to show the position of each substituent clearly in the name.
We are going to explore the alcohol and phenols characteristics. First, let's discuss the physical properties of alcohol. 1. Flammability. Not only alcohols are highly flammable, but they also burn with a clean blue flame. Most alcohol have a sweet smell, exception for glycerol and some lower alcohol. They are odorless. Next, unlike many fuels, alcohols do not produce smoke when burned. Generally, they are colorless liquids at room temperature. Now, let's examine their chemical behavior. Although alcohols are weakly acidic, they can still donate a hydrogen proton. Next, they also react with reactive metals like sodium and potassium. Furthermore, interestingly, primary alcohol are more acidic than secondary and tertiary one because of stability difference in their conjugate bases. Next, let's look at phenols. Phenols are synthetic, but they also occur naturally. When pure, phenol is colorless to white crystalline solid. In contrast to alcohol, it has a strong, sweet and terry smell, often described as medicinal. However, they are often sold as liquid in industrial setting. Finally, let's discuss their chemical properties. Due to stronger hydrogen bonding, phenols are more soluble in water than alcohols. They have a higher boiling point. Finally, it's important to note that they are highly toxic and corrosive, so handling requires caution. Moreover, phenol acidity is much higher than alcohol since the phenolcyde ion is stabilized by resonance.
Now, I will explain the reactions of alcohol. Firstly, alcohol reacts with sodium to form an alkoxide and release hydrogen gas. Secondly, alcohol can undergo halogenation and haloform reactions to produce haloalkenes and iodoform. Alcohol also reacts with carboxylic acids to form esters and water in esterification. In Wilson ether synthesis, alcohol is converted to alkoxide and reacts with alkyl halide to form ethers. Alcohol can also undergo dehydration to form alkenes under acid and heat. Lastly, alcohol can be oxidized. Primary alcohol form aldehydes and carboxylic acid, while secondary alcohols form ketones. I will explain the reactions of phenol. First, phenol reacts with dilute nitric acid in nitration reaction to produce mononitrophenyl. Second, in halogenation, phenol reacts with bromine water to form 2,4,6 tribromophenol. Next, phenol can react with sodium to produce sodium phenoxide and hydrogen gas. Lastly, phenol can also undergo esterification when it reacts with acid chlorides or acid anhydrines to form esters.
To conclude, alcohols and phenols are important organic compounds that can be named using IUPAC rules and classified based on the number of alkyl groups on the carbon with the OH group. Alcohols can undergo reactions like oxidation, dehydration, halogenation, esterification, and more. Phenols react differently due to their aromatic ring, going through reactions such as halogenation, nitration, and esterification. Knowing how to name, classify, and understand their reactions is important in organic chemistry and useful in many real-life applications. So these are our references. That's all from us. Thank you.